Hey everyone, this is the first video for the third chapter for this class, and what's going to be kind of different about this chapter is we're going to be learning a lot of new material that doesn't necessarily review as much anymore, like it was with acid and bases and learning the intermolecular forces again. But this is going to be about thinking of molecules in a different way. And we can basically break down the chapter into three major categories, which is going to be naming organic molecules, doing Newman projections of organic molecules, and then finally looking at chair structures of organic molecules. And each section here will be separated into a couple videos dealing with each chapter, or with each section rather. So hopefully this will provide a good breadth of information for you with these videos. So the first thing I'm going to talk about, right, is nomenclature, right, naming. So what do we mean by nomenclature? We can call it a set of rules to generate names for chemical compounds. And this is going to allow us to talk about organic molecules in a better way, rather than just saying, oh, this molecule here or this molecule there. By being able to name molecules, we'll be able to actually talk about them in a better way that allows us to provide more information, right? So the big thing about the chapter will be alkanes, right? Remembering from our functional group section, that is just fully saturated hydrocarbons, right? The degree of unsaturated is 0, just sp3 carbons with hydrogens attached, right? So some terminology we'll have to get used to, or re-remember, I guess, is, right, hydrocarbons, organic molecules with only carbon and hydrogen atoms attached, and cycloalkanes, right, cyclic groups of single bonded carbons, right? Even though the degree of unsaturation here is 1, right, with a ring, they are still all sp3 carbons, okay? And the final one here is IUPAC, International Union of Pure and Applied Chemistry. So this is going to be the systematic naming system, right, I talked about with nomenclature. We're going to be using this to communicate about the molecules we're discussing. And this will be really important when they become more complex too, because it'll be hard to differentiate one from the other. So we're going to start by looking at this. So this isn't really a naming example, but this is a way, right, to talk about carbons in a different way. These aren't functional groups, okay? This is just some general terminology. So if you look here, right, this CH3 group, we call this a primary carbon, okay? You can also just say this, right, primary carbon. And that just means a carbon, right, carbon with one carbon bond. See that it's attached to one other carbon here, right? But this carbon is a secondary carbon because it is attached to 2 carbon bonds. Right, and tertiary, as you can imagine, is 3 carbon bonds. And finally, quaternary carbon. No surprise, is 4 carbon bonds. Right, this isn't exactly naming, but it is just, again, providing some more information for when we are discussing alkanes. So on to the big thing here, right, naming. So we talked a little bit about it at the end of the last chapter with functional groups, right? I provided you that table of the different number of carbons corresponds to a certain prefix, right? So with 1 carbon, right, we have meth, 2 is eth, 3 is prop, 4 is but, and so on. And so what this just generally means, right, is that when we have 1 carbon, right, a 1 carbon molecule, right, methane is meth, and then the suffix that is ane, okay? When we're naming a molecule, it might be a little bit more complex, right? See here, it's not just 1, 2, 3, 4 carbons, right? It's not just butane, but now there's this extra group coming off of it, right? This extra single carbon group. So how do we name that? It's already named over here, but what is the process, okay? And I'm going to go through the rules of naming, but I might suggest you pause the video and just take a look for yourself, right? Because I'm going to go through this pretty quickly. So, right, so if we're going to name this, right, we didn't know what the name was to start. Wait, how do we do this, right? So find the longest carbon chain. Right, easy enough. 1, 2, 3, 4, right? That is the 4-carbon chain. Even if we started with this carbon, it would still be 1, 2, 3, 4, right? So this is our 4-carbon chain. So we have a root now, right? We have but. Now we have to attach the suffix, okay? So that is butane. Okay. Now 3, number the carbons on the root chain. I guess I technically already did this, right? Start from the end that gives the lowest number where the first branch occurs, right? By first branch, we mean this thing, okay? If we numbered it the other way, we said 1, 2, 3, right? That wouldn't be as low of a number as if we started from the right to the left. So 1, 2, okay? Now that'll be important later on. So here we'll just say, okay, 2. That is where that substituent is. Name the groups attached to the root, right? Attached to this parent chain. In this case, we just have a, as it calls it here, straight chain group, okay? So we use the same root, okay, so it's 1 carbon, right? So it's meth, but we have to end the root with a YL, okay? So that means that is methyl, right? We don't use ane, we don't use ANE, because that is referring to the entire chain, right? YL is referring to a group attached to the root, right? A substituent. We have to assemble the name, okay? In this case, it's not fairly complex. There'll be examples where we have additional things going on, right? More branches. But if different groups are present, we order them alphabetically. And if there are multiple branches of the same type, we'll use these different prefixes to denote that. Okay, and we'll go into some examples of that so it's clear what I'm referring to. Okay, so now let's assemble the name. Okay, so we want to put the substituents first. Okay, and the parent chain always goes at the end. So you can do it one of 2 ways. You can start from the parent chain, right? Just have that at the end and say, okay, butane, and then you can put the substituent next to it. Okay, so say, okay, that's methyl. But now we have to say, okay, where is that methyl group on the butane, right? That is 2, right at the 2 position. Okay, you see that this is kind of how we organize things, right? We go through, find the longest carbon chain, name that, right? Butane, find where the substituents are, right? And then we name the groups attached to the parent chain. Okay, I hope this makes sense, and we'll go through some more examples to get more practice with this. And maybe, again, it'd be best to pause the video and try to do these on your own before I go through them, just for some practice. Even if you get them wrong, it'll be really good to just being able to take a look at these and think about them a little bit before I go through the examples. Okay. So this first one here, exactly the same. I have the Lewis structure here on the side, right? Again, just to emphasize, right, how many carbons there are. So again, going through this, right, we see that there are 4 carbons, right? 1, 2, 3, 4. And we want to make sure when we number these, we want to number so the number of substituents, or the substituent is in the closest position possible. Okay. So again, 1, 2, 4. We know that is butane. Okay. At the 2 position, we have that methyl group, so we know we have a 2-methyl here. So organizing these things together, we have 2-methylbutane. Great. So now looking at the next example, we see everything is a little bit longer now. Okay. So looking through this, how do we know which chain's the longest? Just go through and number everything, right? So let's do 1, 2, 3, 4, 5. Okay, now is that really the longest chain? So if we go through and try to number the other ones, right, if we start from the top, 1, 2, 3, 4, 5. Okay, so it looks like everything is basically identical, right? It doesn't look like there's any difference one way or the other which way we go. So we'll erase these. So we know that is our longest chain, right? So we know that is, just a different color, we know that this is pentane, okay? Again, pent for that 5, and then ane again for the parent chain, okay? Now looking through, Now, which way is the shortest way to get to that substituent? Right, this group here. 1, 2, 3 is that way, but if we go the other way, it's also 1, 2, 3. So it doesn't matter which way we go. The symmetry on both sides. So we would say, okay, this group here, right, we know that's 3, but what's that substituent called, right? We know there's 2 carbons there, right? So we know it's F, and then we have to attach that YL to the end. So this molecule is 3-ethylpentane. Now let's go to this last example here. It looks a little bit more complicated. So how do we do this? Okay, we go through and we can think, okay, what's the right way to number this? So starting from the bottom, do 1, 2, 3, 4, 5, 6. Okay, so we can think, okay, that's hex. Okay, hexane. But is that the longest parent chain? So let's go through and see. We see right above where 2 is, we see there's actually 2 carbons there, so that one might be longer. So going through 1, 2, 3, 4, 5, 6, 7. Okay, so that's actually longer, right? So we have to go with that as our parent chain. So now that is heptane. Right, so we know it's not hex, but it is hept. So next, we have to try and number these groups. So how do we do that, right? We have to think, okay, which is the best way to go through and number these, right? We might say, okay, looking at, right, we have that third carbon here, so that is 3-methyl, right? And then next to it, we have that 5, that is 5-ethyl. But is that the right numerical order for these things, right? Because you can see we could number it the other way, right? We could do 1, 2. Actually, let me do this in a different color here. We do 1, 2, 3, 4, 5, 6, 7, right? And that would kind of switch the positions down here, right? Instead, we would have 3-ethyl and 5-methyl. Okay. And the reason why we want to do this, I'm actually going to erase this up top and do it in a different color so it's clear what I'm referring to. The reason why we want to do this is because alphabetically or numerically we want the numbers to be to match alphabetically, right? So E, right? E comes before M, so we want the numerical order to be the same, right? Even though there's no lower number than the other when we're looking at these things. Alphabetically, we want to make sure that the lowest number the lowest alphabetical letter has the lowest number, right? So what's in green here is going to be what we want, okay? Now, naming is a little bit tricky because it's not as quote-unquote scientific. It's just a list of rules that are used to name things, all right? So we always want to be kind of systematic and adhere to them, right, when we're naming things. So in this case, we would say that this is, so we have some more room, right? So we want to put these in alphabetical order going through. So we'd say this is 3-ethyl, 5-methyl heptane. Okay. And there's a lot of like little things here to know too. See, there's a dash between the number and the next substituent. And if you have another substituent, you put a dash there. But in the final substituent, you don't have a dash between that and the parent chain. Okay. And little things like that we'll just get used to as we keep naming these things. So we have this example here, which looks like we have 3 substituents, and we'll go ahead and name this together in lecture, but I encourage you to give it a try, or at the very least, go back and look at the other examples I gave you, erase what you did, and just try and name it again and see if you get the right answer the second time around.